The year was 1943. Across the vast, shimmering expanse of the Southwest Pacific, American air power was struggling to gain a foothold. The United States had its weapon of promise, the Lockheed P-38 Lightning. It was a marvel of modern engineering, a twin-engined, twin-boomed beast that looked like nothing else in the sky. Pilots loved its stability, its immense range, and its terrifying concentrated firepower, a 20mm cannon and four 50-caliber machine guns mounted right in the nose. The P-38 was faster than anything the Japanese could field, especially at altitude, and its boom and zoom tactics were supposed to make the enemy obsolete, but in the thick, humid air above New Guinea and the Solomon Islands, the promise was turning into a paradox of death. The adversary was the Mitsubishi A6M Zero. The Zero was slow, lightly armed, and fragile, but it possessed a terrifying advantage: unrivaled maneuverability. It was a ballerina with a gun. In a close-quarters dogfight, the kind of turning and twisting that inevitably happened when pilots got drawn into the fray, the Zero could execute turns tighter and faster than the P-38 could hope to follow. The P-38 pilots, men who had trained on the speed and power of the Lightning, were dying. They would spot the Zero, dive to attack, and if they missed the first pass, the fight devolved into a turning circle. The Zero pilot would simply haul the stick back, and the P-38, heavier and with a higher wing loading, would watch helplessly as the Zero zipped inside its turn radius, lining up for the kill. Reports flooded back to 5th Air Force Command. The P-38 is too sluggish to turn. Its roll rate is too slow. The controls are too heavy. The mechanics and crew chiefs at the forward airfields, places like Dobodura in New Guinea, felt the casualties acutely. They were the ones who saw the empty cockpits return, or worse, failed to return at all. They lived in the sweat and dust, maintaining planes that seemed to carry a fatal, inherent flaw. 37 P-38s had been lost in just 6 weeks in one sector alone, a devastating, unsustainable attrition rate. The official word from Lockheed and the USAAF engineering was rigid and frustratingly technical. The aircraft is operating within specifications. Pilots need to adapt their tactics to the Lightning's strengths, speed, and altitude. This pronouncement, delivered from clean, air-conditioned offices far from the smell of burning aviation fuel and cordite, only fueled the frustration. The manual stated the cable tension had acceptable tolerance for slack. That acceptable tolerance translated in the air to a noticeable, often fatal 3/8 of an inch delay between a pilot moving the stick and the aileron truly biting the air. This was the chasm between theory and reality. The engineers knew physics, the pilots knew tactics, but it would take a mechanic, a man who worked with his hands, who understood cable tension and simple leverage better than any slide rule, to bridge that gap. The lives of the pilots depended on solving a problem that the design manuals claimed didn't exist.
The problem was insidious, residing in the microscopic tolerances of mechanical engineering. The ailerons, the control surfaces on the trailing edge of the wings that govern the aircraft's crucial roll, were connected to the pilot's stick by a system of cables, pulleys, and bell cranks that stretched the entire length of the twin booms and wing structure. To prevent the cables from snapping under temperature changes or high G stress, official specifications mandated a slight degree of slack or tolerance in the system. In the fast, high G environment of a Pacific dogfight, this tolerance was deadly. The Zero, built for lightness and extreme maneuverability, had tight, responsive controls. When a Zero pilot jammed his stick to the side, the plane rolled now. When a P-38 pilot did the same, that 3/8 inch of slack had to be taken up first. It was a minuscule moment, a fraction of a second, but in the 300+ mile-per-hour knife fight of a dogfight, that fraction was the difference between life and death. The situation was psychological warfare disguised as mechanical failure. Pilots began to subconsciously distrust their aircraft's responsiveness, pulling harder on the stick, overcompensating, which sometimes led to the more complex high-speed issues like aileron reversal, a separate high-speed flaw that would be fixed later, but the sluggish roll was the immediate killer in turning fights. One pilot in particular, Lieutenant Robert Hayes, was a magnet for bad luck. Hayes was a competent fighter pilot, aggressive and dedicated, but he had recently survived 3 harrowing encounters where his P-38 had failed to roll quickly enough to escape a Zero's guns. He was now on his second P-38 in 6 weeks. He and every other pilot at WWII felt the pressure of the unfixable flaw. The mechanics watched the toll this took on them. They were accustomed to battle damage, bullet holes, shrapnel tears, busted engines. Those things were tangible. They could be fixed with sweat, wire, and wrenches. This flaw was untouchable, a flaw written into the Army Air Force's manual itself. An engineering officer at the base, exasperated by the persistent complaints, once dismissively stated that the cable tension was optimal for structural longevity, not for suicidal turning. That statement summed up the official line. The aircraft was mechanically sound. The pilots were simply demanding too much. The problem wasn't a failure of parts, it was a failure of doctrine. Doctrine demanded structural integrity above all else. Combat demanded instant response. It was a fight between the engineering rulebook written in California and the survival instinct of a pilot over the jungles of New Guinea. The mechanic who would dare to challenge that doctrine would have to be either brilliant or incredibly desperate. He would have to risk not just his career, but a court-martial by knowingly tampering with the primary flight controls of a combat aircraft. The man who bridged the gap between the battlefield and the blueprint was Technical Sergeant James McKenna. McKenna wasn't an engineer. He was a boots-on-the-ground aircraft mechanic with the 5th Air Force, based at WWII. He was a man whose expertise was derived not from a technical college, but from thousands of hours spent kneeling in the mud, covered in grease and sweat, with the twin tails of the P-38 looming over him. McKenna didn't rely on complex aerodynamics tables. He relied on feel. He was the kind of mechanic who could diagnose an engine flutter by the faint click it made it idle. He treated the P-38s as living, breathing machines, intimately familiar with every vibration, every loose cable, and every worn rivet. He knew that the aircraft, despite its speed, felt heavy and reluctant when the pilot asked for a sudden roll. He knew where the manuals were wrong. For weeks, McKenna was consumed by the problem. He watched the pilots, he listened to their debriefs, and he meticulously checked the control cables on every P-38 that came back. He would grab the control yoke in the cockpit and feel a dead zone, that slight unresponsive slack before the tension took hold. He measured it precisely, 3/8 of an inch of wasted stick movement. He tried everything within regulation, adjusting the pulley tensioners, swapping out cables, and checking for wear. Nothing worked, because the mandated specifications required that slack. To remove it would be to exceed the tension limit set by Lockheed, potentially risking a cable failure during extreme stress, an error punishable by severe military justice. The stress on McKenna and his crew was immense. The high-pitched whine of the Allison engines going out on a mission was mixed with the silent, sinking dread of knowing which plane might not return. McKenna had watched 2 friends, 2 pilots whose planes he had personally maintained, failed to return because their P-38 simply rolled too slowly. The loss was personal, and the feeling of helplessness was a corrosive agent. On the evening of August 17, 1943, after watching Lieutenant Hayes prepare for a mission the next morning, McKenna reached a breaking point. Hayes, usually buoyant, looked defeated. He knew the odds were stacked against him. McKenna looked at the P-38, a magnificent machine being crippled by a technicality, and he decided that engineering bureaucracy was a far less dangerous enemy than the Zero pilot. He decided that if the official parts couldn't remove the slack, he would find a way to make the slack disappear himself. He was going to violate every maintenance protocol in a book because the regulation was actively murdering his pilots. That night, under the dim, buzzing lights of the maintenance hangar at WWII, or perhaps working in the deep shadow of the jungle-fringed dispersal area, Technical Sergeant James McKenna performed the operation. It was a study in simplicity and front-line ingenuity, a solution born of necessity, not a university degree. McKenna bypassed the complex official tensioning system. He located a specific point in the aileron cable run where the slack was most pronounced and accessible. He took a simple 6-inch length of piano wire, a material not approved for flight control surfaces, or perhaps just a length of extra strong steel safety wire. He bent the wire into a distinct Z shape. The Z shape was the genius of the trick. It wasn't a tight, unforgiving tensioner that risked snapping the primary cable. Instead, the Z-wire was rigged to mechanically take up the initial fatal 3/8 inch of slack in the system before the main cables were placed under load. The moment the pilot moved the stick, the tension was immediate. The aileron responded instantly. Crucially, under the extreme stress of a high-G maneuver, the Z-wire itself was designed to flex slightly, protecting the primary cables from over-tensioning. It was an unauthorized, non-standard, and utterly unscientific modification. To an engineer in California, it would have looked like crude, dangerous hacking. It was the mechanical equivalent of a baling wire fix on a multi-million-dollar fighter. McKenna worked quickly and silently. He chose Lieutenant Hayes' P-38 for the inaugural test, knowing Hayes' mission was scheduled for dawn. He didn't tell Hayes, or his crew chief, or anyone else. His primary concern was getting court-martialed if the plane crashed, but he accepted the risk. The cost of inaction was higher. The next morning, McKenna stood near the runway as Lieutenant Hayes taxied out. The Z-wire modification took 8 minutes to install, but the wait for the result was excruciating. Hayes climbed into the clear New Guinea sky, unaware that his plane was no longer flying within specifications. He was simply flying a P-38 that finally felt right. He was flying the P-38 that Lockheed had intended to design before the engineering protocols got in the way. McKenna could only wait for the sound of battle to begin and hope he hadn't just sent a good man to his death with a piece of bent wire.
The mission that morning was a standard patrol over the nearby Japanese-held coastline, expected to encounter escorting Zeros protecting a supply convoy. McKenna waited by the radio shack, the static crackle the only soundtrack to his mounting anxiety. Lieutenant Hayes engaged the Japanese patrol above the designated zone. The fight began, as always, with the P-38s diving in a boom and zoom pass. Hayes targeted a Zero and missed his initial burst. Predictably, the Zero pilot hauled his stick back, initiating a high-G tight turn, confident that the P-38, now committed, would be unable to follow or escape cleanly. But this P-38 was different. Hayes instinctively threw the stick to the side, expecting the familiar momentary lag, the heavy reluctance. Instead, the P-38 snapped into the roll with startling instant authority. The 3/8 of an inch of slack was gone. The aircraft responded exactly when Hayes commanded it. Shocked but elated, Hayes found himself not outside the Zero's turn radius, but suddenly inside it, cutting the corner. The surprised Zero pilot, accustomed to the P-38's slow roll, was caught completely off guard. Hayes lined up the Zero and unleashed the concentrated torrent of his nose guns. The Zero exploded in a flash of fuel and debris. The rest of the fight was a revelation. Hayes fought like a man freed from shackles. The P-38, suddenly responsive, could now hold its own for the critical initial seconds of a turn fight, allowing Hayes to leverage its superior speed and altitude to escape or press the advantage. In the span of just 7 minutes, Lieutenant Hayes, the pilot who was due to be shot down any day, dispatched a total of 3 Zeros. He returned to WWII not just victorious, but ecstatic. McKenna jumped out of the cockpit, his face shining with sweat and adrenaline. "Mac, what did you do to my bird? It's a miracle! It rolled like a Spitfire!" McKenna, relieved beyond measure, played dumb until they were safely away from any commissioned officers. He then cautiously revealed his secret, showing Hayes the crude, illegal Z-wire rigging. Hayes didn't criticize the violation of protocol, he grasped McKenna's greasy hand. He knew the difference between a pilot dying and a pilot surviving had been less than an inch of bent metal. The word spread like wildfire, but it was kept strictly among the pilots and the mechanics. They called the fix the McKenna wire trick, or sometimes the WWII fix. The immediate consequence was the preservation of a pilot's life. The greater consequence was that the P-38 Lightning, the fighter with the fatal design flaw, had just found its true combat identity. The McKenna wire trick was immediately adopted as unofficial standard practice. The pilots of the 5th Air Force, once skeptical of their mounts, demanded the fix. In the clandestine atmosphere of the forward airfields, far from the eyes of Washington and Lockheed engineers, the mechanics became the true heroes. The fix was simple, cheap, and fast, taking only minutes per plane. Within weeks, over 43 P-38s across the Southwest Pacific had been illegally modified. The data that soon followed was undeniable. The kill-to-loss ratio for the P-38s improved dramatically. Before the fix, the Zero had maintained a marginal advantage in the turning fight, often leading to a negative exchange ratio for the Americans. After the McKenna wire, the P-38 could now confidently enter a close dogfight, knowing its instant roll rate gave the pilot the chance to execute a clean break, or better yet, to quickly line up on the slower Zero. The improved roll rate meant the P-38 could now execute the hit-and-run, or boom-and-zoom tactics, with a much higher safety margin. If the pilot missed and the Zero started to turn, the quick roll allowed the P-38 to brake cleanly, climb back to altitude using its superior engine power, and reset the engagement. The aircraft was finally fulfilling its design promise. The Japanese pilots quickly noticed the change. Their combat reports from late 1943 began to mention a troubling and new development. P-38s were maneuvering in ways they shouldn't. The Zeros, which relied on the predictable slow roll of the American twin-boom fighter, were increasingly caught off guard. The psychological edge which the Zero had maintained for so long began to erode. McKenna and his colleagues became legends among the ground crews. They were the ones who truly won the air war in this sector, not through courage in the air, but through mechanical courage on the ground. They faced daily risks, an unexpected inspection, a random engineering audit, or the terrifying possibility that their non-standard fix would lead to a catastrophic failure. The tension was constant. Pilots were under strict orders not to mention the fix in their official debriefs. Mechanics learned to camouflage the simple Z-wire, ensuring it looked like standard equipment, or simply lying if questioned. The entire operational air wing was running a massive, successful conspiracy against its own technical superiors. It was a clear demonstration of the wartime reality. The men closest to the fight often find the solutions that the high-level bureaucracy misses. The success of the P-38 could only be hidden for so long. The rapidly improving kill ratios and the enthusiastic reports from the pilots eventually forced the USAAF and Lockheed to investigate the discrepancy. Why were the P-38s in the Pacific suddenly performing so much better than those in the European theater, which was struggling with different high-altitude issues? A team of Lockheed engineers and Army Air Corps technical inspectors was eventually dispatched to the Pacific to find the root cause. Their mission was either to validate the pilots' claims of a design flaw or prove that the pilots had simply mastered new tactics. The inspection team was meticulous. They spent days poring over maintenance logs and interviewing pilots and crew chiefs who gave carefully rehearsed, non-committal answers. But engineers are trained to spot non-standard modifications. It was inevitable that they would eventually find the unauthorized Z-wire. The discovery was initially met with shock and hostility. The engineers were outraged that a non-commissioned officer had taken it upon himself to illegally modify the primary flight controls of a combat aircraft. The initial response was to demand that the modifications be immediately reversed and that McKenna be subjected to a court-martial for gross negligence and willful disregard of safety protocols. However, the field commanders, the generals and colonels who had watched their men die and who now saw undeniable success, intervened. They looked at the kill reports, they listened to Lieutenant Hayes' impassioned testimony, and they looked at the simple 6-inch piece of wire. The evidence of its effectiveness was overwhelming. They could not court-martial the man who had saved the lives of nearly 100 American pilots and given the P-38 its air superiority. The engineers were forced to conduct a full official assessment of the McKenna fix. Their wind tunnel tests and stress analysis confirmed the truth. The simple Z-wire effectively tightened the controls without introducing an unacceptable risk of cable failure. The slack was truly unnecessary.
The decision was made to integrate the fix into the production line. Lockheed quietly modified the internal structure of the P-38 to eliminate the cable slack permanently. The official documentation referred to the improvement as a field-suggested control modification or a revised tension specification, completely omitting the name Technical Sergeant James McKenna and the illegal piano wire origins of the change. The bureaucracy had caught up, legalized the stupid trick, and promptly erased its history.
Technical Sergeant James McKenna was never officially recognized for his revolutionary, life-saving invention. He received no medals, no commendation, and certainly no patent or royalty checks from Lockheed. His name does not appear in the official engineering change orders or the revised P-38 maintenance manuals. He was simply transferred to another base, a quiet acknowledgement from the command that his insubordination was a necessary evil. The P-38 Lightning went on to become one of the most successful and enduring fighters of World War II. It was the plane of choice for high-scoring American aces like Richard Bong and Thomas Maguire. It became famous for the high-profile interception and shooting down of Admiral Isoroku Yamamoto, the architect of Pearl Harbor, a mission that required extreme range and precision. Every single subsequent P-38 to roll off the assembly line, including the P-38J and P-38L models, incorporated the principle of instantaneous control response, the direct mechanical descendant of McKenna's Z-wire. The true legacy of James McKenna lives not in engineering reports, but in the untold stories passed down through the ranks. Pilots who flew the modified P-38s knew. Crew chiefs who installed the Z-wire knew. It became a legendary reminder that the greatest innovations often come from the most unexpected places. From the men who face the problem daily, whose hands are covered in oil, and whose sense of reality trumps the theoretical perfection of the drawing board. McKenna's stupid wire trick serves as a timeless lesson in military history. A 6-inch piece of bent piano wire inserted without authorization saved approximately 80 to 100 American pilots' lives and fundamentally shifted the balance of air power in the Pacific, transforming the promising P-38 into the zero-killing machine it was destined to be. The true heroes of any war are often the unsung technicians, the mechanics, the logisticians, the sergeants, who, when faced with an obstacle, don't consult the manual but find the solution. James McKenna was one such man, a quiet genius whose refusal to accept a flaw that was killing his friends gave the P-38 Lightning the instant roll and maneuverability it needed to dominate the Pacific skies. He proved that sometimes the simplest, most unauthorized solution is the only one that truly matters.